Hi class, this video is to help you find the sample using systematic sampling. So here's a problem. A sample of size 6 is taken from a population of just 81 people. Okay. First, you need to find K. And you find K by taking the population, the total number of people in your population, 81 here in this case, and dividing by your sample size, n. Remember, in systematic sampling, we want to sample like every 4th person or every 6th person or every 10th person. What we want to do is we don't want to make the K is our number, the spacing between the people we sample. So that's the we're going to say every 4th person, we say, or every 5th person, or every Kth person. Okay, and so if we make this number really small right here, like if we say every other person, if we make K1, so you just skip a person, then what would end up happening in this situation would you say, okay, well, we're not going to sample the first person who walks in, but we would sample the second one. And then we wouldn't sample the 3rd person that comes in, but we would sample the 4th person. If we wouldn't sample the 5th person, but we would sample the 6th person. And then we wouldn't sample the 7th, we would sample the 8th person. And so you could see 1, 2, 4, 6, 8, 1, 2, 3, 4. We're going to get to our sample of 6 really quickly. And here's 12. Okay. Let's see. So we have the circle of people are the people in our sample. So 1, 2, 3, 4, 5, 6. So by customer number 12 walking in the store, if it's a store, we're trying to sample the customers that come in the store. By customer number 12, we already have our sample of 6. And then the 13th, 14th person that walks into the store, 15th person, 16th person, none of those people would be ever sampled at all. The problem with this is that like our number K, this is an example where we had K equal to 1. It's so small compared to our population size that the people are all bunched together, and we're getting everybody in the morning, and we're getting nobody that's coming in the store in the afternoon. So it's a bad problem. We want to be able to space them out, especially with a customer kind of like situation, because the store, it looks different in the evening when it might be dirtier, when it's different staff working, than it looks in the morning. So we don't want, to do all of our samples all clumped together. And like, so if we have a big population, we want to choose a larger K, so we might choose 10 or so, it would be a better choice for K. It would be 10, then the 10th, the 20th, the 30th, and at least there we would get closer to 81. Our last person would be kind of close to 81, right? But to even get more scientific, get even more detailed, to make it even spaced out to the most possibly spaced out they could be, we choose a K what we do to find K is take 81 and divide by 6. Okay, so that would equally space these Ks out. So 81 divided by 6, and this will be our K, and it is n divided by the little n, which is sample size. So in our case, 81 divided by 6. And let me find that quickly. So that's 13.5. Now if we round up here, the problem we're going to run into is that we would not when we go to find that last person in the sample, it would actually be larger than 81. In this case, we only have 81 customers. So we don't want the last person for us to sample to be the 82nd person, because we don't have an 82nd person coming in the store. So we have to round this number down. And like I said, we could have just, well, I just estimated 10. So it's okay if it's not exact. We just want to get, I mean, for our purposes for this class, we want to follow this process and we want to all get the same answer here. But the idea is that these people are spaced, that we were putting in our sample, are spaced out to the most spaced out they can be. So 10 would have been kind of good, but like 13 is best. But 14 would be too far spaced out. And what would happen is when I get to 81 and I go to pick my final sample, like I said, 82 would be the person I want to sample, and there is no 82. And we wouldn't find a sample of 6 doing it that way. We would have that spaced out too much. Okay, so we want every 13th term. So we found K, that's our first step here. The second step is to pick a number between 1 and K. Now, the idea here is that there are 6 groups of 13.5 in 81. Or we could think about it, there is 13.5 groups of 6 in 81. So from each of those 13.5 groups, we'll just say 13, okay? Because there's definitely, if there's 13.5 groups of 6 in 81, there's definitely, at least 13 groups of 6 in 31. There's actually more than 13 groups of 6 in 31. So there's definitely 13 groups of 6 in 31. From each of those 13, I'm gonna say 31. In each of those 13 groups, I want to choose one number to be in my sample from each one of the 31 groups. So, 13 groups, sorry. So they choose a number randomly between 1 and 13 because they're picking one number in that first group. So I circled the people to be in a sample, right? We're picking one number in that first group of 13 to be in a sample. So within these first 13 people, I have to pick one person to be sampled within that first 13. So they said, let's pick 11. And in this problem, they already picked that number between 1 and K for you. It's 11 in my situation. So they said, okay, let's pick number 11 is going to be the one in my sample. Then what they do is they add K to this number, which is 13. So 13 plus 11 is going to be 24. So that's going to land in the second group of 13. And every time we add 13, it's going to get you into the next group of 13. And there's going to be 6 groups of 13 in 81. So we're going to be able to get 6 samples, the sample size that we want. So this is the next person sampled, is this, and then in the next group of 13, then you would sample number 37, right? Because 24 plus 13 would be 37. So because we know there's 6 groups of 13 and 81, we're going to make sure that we get all of the 6 samples that we need. And we're going to, because 13 was the largest number that is not a decimal number, that's in, goes into, that 6 that goes into 81 6 times, then we know that it's spaced out as much as we could space it out. Okay, so they did step 2 for us, finding this 11. Now to find the second and third and fourth terms, which I was doing over here, then you just take the first term and you add your k. In my situation, it was the 13. So that's how we got the 24. And I circled the 24. Then it said, what's the next number of the term? Well, you add another 13. 37, that's where I got the 37. That's why I was circling 37 over there. And then you add another 13 to the previous number, and that gives you, right, 50. So these are the first 4 people to be sampled in a population of 81, is 11, 24, 37, and 50. So this follows it. You could just take the term and add your k, 13, to get the next term in the series. That's one way of doing it. Or you could follow the formula way, and that is, the formula way is p plus k, p plus 2k, because we added 2k. We added the original number p plus 1k to get the first term, and then the original number p plus 2k to get the third term, and this is the p to get this term. We took the original number and we did 3k's. And so if they did ... and they asked you for the last term in this series, the last person to be sampled, that is p plus, so this is the first term, that's the second term, the third term, the fourth term. So the fourth term, we need to add 1 less k than that is the number term, right? So I added 2 k's for the third term, I had 1 k for the second term, and so on. So this is n minus 1 k's that I have to add to get the very last term. Okay, this is the formula that will give you that last term. But in this case, they don't ask for that, but just in case in the next problem they do. All right, bye, have a great day.